So a complex number has a real and an imaginary part. The symbol for complex numbers that you will go ahead and usually see is a C with a double line here. A complex number is always going to be written in the form A plus BI. It must be in this form where the first part is the real part of the number and the number in front of B is the imaginary part. So just as a quick review, what we have is anytime we have the square root of -1, that is equal to I. So let's go through a few things. By definition, anytime you have I squared, that is equal to -1. To keep going with this, if I have I to the third power, that's the same thing as saying I squared times I. And as I just said, anytime you have I squared, you replace that with -1. So that is equal to -1 times I. So I to the third is just equal to -I. And then the last one that we'll do is I to the fourth, which is the same thing as saying I squared times I squared, which is -1 times -1, again, from the same reason that I had up here. And every time I have I squared, it's equal to -1. So I to the fourth power is always equal to 1. This goes in a circle. As you are going around and doing this, it goes from I to I squared to I to the third, I to the fourth, and back to I. And those values again, I squared is equal to -1, I to the third is -I, and I to the fourth is 1. So again, it's 1, I to -1 to -I to 1 back to I. Now where this becomes important is if we are going through and looking at different powers. So if I have I to the fifth, you want to break that down to, that's I to the fourth times I to the fourth, we know is up here, and I to the fourth is equal to 1. So that's the same thing as saying 1 times I, or just I. This goes for any larger number that you have. Let's say it was I to the 20th. That is the same thing as saying I to the fourth. And I raise that to the fifth power. Now, why am I doing this? Because I know that when I raise an exponent to an exponent, that is equal to 20. So I work on the inside of this first. I know that I to the fourth, again, is equal to 1. So all of this is equal to 1 to the fifth power, which is equal to 1. Now, the question I always get is, how do I know how to break up the exponents? Well, the way I know how to do that is I take anything that is I to the n. So any I that has an exponent here, what you want to do with that is you want to take that value of n and divide it by 4. So what I have up there before, my exponent was 20. So that means I have 4 divided by 20, which is 5. There is no remainder. So that's why I knew to break 20 into 4 times 5. Now that won't always go evenly. So let's say you had something else. So obviously it will not always go in equally. Let's do another question. Let's say it was I to the 22nd. Again, I take the 22 and divide it by 4. I know that it still goes in 5 times. But now my remainder is equal to 2. So let's break this down. That's the same thing as saying I to the 20th times I to the 2nd. And just as a brief review, when we're dealing with exponents, remember when you multiply variables, we add exponents. So that does equal I to the 22, all right? So as we just said, I to the 4th to the 5th power, this is equal to 1, times I squared, which is negative 1. So all of this will equal negative 1. Let's go ahead and do another one. Let's say you had I to the 103 power. First thing, again, I'm going to take that 103 and divide it by 4. And again, I'm always using 4 because I know I to the 4th power is equal to 1. So I go ahead and put in there. That goes in 25 times. 4 times 25 is 100. I get a remainder of 3. So I break this down, and this is I to the 4th power raised to the 25th power times I to the 3. Now, just for clarification, this will always be the remainder. I to the 4th, because I'm dividing by 4, that will always be I to the 4th. That will never change. And whatever power we have here is the quotient. But again, by design, all of this will always equal 1 times what we are left with as far as the remainder, I to the 3rd power. And I know that I to the 3rd power is equal to negative I.